Increase in age. Arun's present age is 40% of Barun's. Arun and Barun. Barun's age were 5x, Arun's age would be 2x. In another few years, Arun's age will be half of Barun's. And let's say another few years, let's take y more years later, Arun would be 2x plus y years old, and Barun would be 5x plus y years old. This is twice of this. 2 times 2x plus y is 5x plus y. 4x plus 2y is 5x plus y, or y equals x. Or Barun's age goes from 5x to 6x. By what percentage did it increase? 20%. It goes from 5x to 6x, percentage increase is 20%. Very simple question. A person can complete a job in 120 days. He works alone on day 1. On day 2, he is joined by another person, so 2 people, who can also complete the job in exactly 120 days. On day 3, he is joined by another person of equal efficiency, so 3 people. Like this, every day a new person with the same efficiency joins the work. We count man days of work. 1 man day gets done, 2 man days get done, 3 man days get done, 4 man days get done, 5 man days get done, and so on. So at the nth day, n man days will get done. Total work done would be n into n plus 1 by 2, which is 120. Or n into n plus 1 is 240. Not going to imagine the quadratic. 15 square is 225. This is close to 15. This is 15 into 16. How many days are required to complete the job? 15 days. 1 plus 2 plus 3 plus 4 plus 5 all the way till 15 will add up to 120. An elevator has a weight limit of 630 kilograms. It's carrying a group of people of whom the heaviest weighs 57 kilograms and the lightest weighs 53. What is the maximum number of people in the group? For maximum number of people, we should have maximum number of people weighing this. So out of 630, subtract 57. 10 minus 7 is 3. 12 minus 5 is 7. 573. Wonderful. Now there's one guy who should have weighed this much. Set aside that guy, and then the remaining all should weigh this much. 573 divided by 53. So 53. 10 people. 10 people weighing 53 kilograms and 1 weighing 57. And so an elevator has a weight limit of 630 kilograms. 10 people weighing 53 kilograms and 1 weighing 57 will take us to 530 plus 57, 587. We have room for another 43 kilograms, which can be offset by having more people weighing 53 kilograms. So we have what is the maximum possible number of people in the group. So we have 11 people. We could have 1 of 57 and 10 of 53, but we cannot have 12 people in this group. Fine. So 53 into 11 plus 57 is greater than 630. So that doesn't work. 11 people with 1 weighing 57 and the rest weighing something less than that, but greater than 51. 53 or greater will work. So 53 into 10, 530 plus 57 takes us to 587. We have another 43 to get. So assorted different combinations, or some combination can take us to 630. But what is the maximum number of people in the group? This is 11. We cannot have 12 people in this group. Fine. So 12 people in this range is not possible. A man leaves his home and walks at a speed of 12 kilometers per hour, reaching the railway station 10 minutes after the train had departed. If instead he walked at a speed of 15 kilometers per hour, he would have reached the station 10 minutes before the train's departure. Let's say the distance is D. He can travel at 12 kilometers per hour and 15 kilometers per hour. In this, he takes T plus 10. In this, he takes T minus 10 minutes. Or I'm going to do this very differently. Time taken in this instance is d by 12. This distance is d by 15. D by 12 minus d by 15 is 1 by 3. Wonderful direct way of doing this without worrying about the time t. What are we doing here? The difference between these two times is 20 minutes. Time taken for this, time taken for this. The difference between these two is 20 minutes. We take the distance in kilometers and speed in kilometers per hour. We'll get the answer in hours. The difference is 20 minutes, which is 1/3 of an hour. And then we are done. So LCM is 60. 5d by 60 minus 4d by 60 is 1 by 3. Or d by 60 is 1 by 3. D is 20 kilometers. Ravi invests 50% of his monthly savings in fixed deposit. 50% of the rest of his savings is invested in stocks. 50% in FD. The rest is 50%. 30% of this is invested in stocks. So stocks is 15%. The total amount deposited by him in the bank for savings account and fixed deposit is 59500. Total amount deposited by him, which is this 50% plus the remaining 35%. 85% of X equals 59500. Find X. X equals 59500 by 85 into 100 by 0.85 effectively. Divide by 5, this becomes 17,119. 119 by 17, 17 goes into it 7 times, or X is 70,000. Or Ravi earns 70,000 rupees. 35,000 he puts as FD, and then some 10,500 he puts as savings into stocks. The remaining he keeps in a savings account, and what he puts in FD and savings account add up to 59500. If a seller gives a discount of 15% on retail price, she still makes a profit of 2%. So there is mark price, you say X, selling price is 0.85x. This is equal to 1.02 times cost price, because she still makes a profit of 2%, or 0.85, 1.6, 0.17 into 5, 0.17 into 6, or selling price, which is 0.85x, is 1.02 CP. Think about this. X equals 1.02 by 0.85 CP. This is 6 by 5 CP. Which of the following ensures that she makes a profit of 20%? If X were her selling price, she'll make a profit of 20%. Or she should not give any discount. No discount, no discount, no increase. Sell at retail price. So the discount makes her price clash. If the selling price were X, then X is 6 by 5 times CP. That'll be a 20% profit. So she should not give any discount if she wants to make a profit of 20%. A man travels by a motorboat down a river to his office and back with the speed of the river unchanged. If he doubles the speed of his motorboat, then his total travel time gets reduced by 75%. The ratio of original speed of the motorboat to the speed of the river is, let's say, it goes down and then comes back up. Let's say his boat speed is B, stream speed is S. Going down, he has B plus S. Coming up, he has B minus S. Right, so some distance by B plus S plus the same distance by B minus S is time taken T. If he doubles the speed of his motorboat, D by 2B plus S plus D by 2B minus S, the time reduces by 75%, or this becomes T by 4. We need to find original speed of the motorboat to the speed of the river. We need to find B is to S. This holds good. And so I'm going to remove T and D from this equation by dividing one by the other. If you divide this equation by this equation, D gets away. We'll have 1 by B plus S plus 1 by B minus S divided by 1 by 2B plus S plus 1 by 2B minus S to be equal to 4. Fine. Let's simplify this. I'm going to take the LCM in the numerator, LCM in the denominator. So B minus S plus B plus S by B square minus S square divided by 2B minus S plus 2B plus S divided by 4B square minus S square equals 4. The S gets knocked off, S gets knocked off. This is 4B and this is 2B. So 2B by B square minus X square into 4B square minus S square by 4B equal to 4. The B gets knocked off. We have a 2 here. 4B square minus S square by B square minus S square is 8. We want to find original ratio of speed of motorboat to that of river. We want to find B by S. Let's say we say B by S is equal to K. And further, let's say B by S, the whole square is equal to K. This is 4K minus 1 by K minus 1 is 8. 4K minus 1 is 8K minus 8. 8 minus 1 is 4K, or K is 7 by 4. Or the ratio we are looking for, the square root of 7 by 4 or root 7 is to 2. Wonderful question, not too complicated, but layers of computation and solving algebra involved. Get some practice into boat and speed idea, this should be through. Suppose C1, C2, C3, C4 and C5 are 5 companies. Profits made by C1, C2 and C3. C1, C2, C3. Profits are in the ratio 9 is to 10 is to 8. Profits made by C2, C4, C5 are in the ratio 18, 19, 20. This is 10, this is 18. LCM is 90, so reject this. This becomes 90. This is 81, 81, 90, 72. Becomes 90, 95, 100. So the ratio is 81 is to 90 is to 72 is to 95 is to 100, all in terms of X. C5 has made a profit of rupees 19 crore more than C1. C5 is 19 crore more than C1, or this is 81 crore, 90 crore, 90 crore, 90 crore, 100 crore. The difference 100 minus 81 is exactly 19. Total profit made by all of them put together, the sum of all this. 5 plus 2, 7, 7 plus 1, 8, 8. And 8 plus 9, 17 plus 7, 24 plus 9, 33, 438 crore. Choice A, done. Just transitioning two systems of two sets of ratios. The number of girls appearing for an admission test is twice the number of boys. So boys, twice the number of boys. If 30% of the girls and 45% of the boys, 0.45B and 0.6B get admission. So 1.05B get admission. The remaining 1.95B do not get admission. As a percentage, 1.95B by 3B into 100, which is 65%. 65% do not get admission. In a market, the price of medium quality mangoes is half that of good mangoes. Medium quality and good quality. 2x, x. A shopkeeper buys 80 kilograms of good quality and 40 of medium quality mangoes, and then sells all these at a common price, which is 10% less than the price at which he bought the good ones. So good ones are 2x, 10% less than that is 1.8x. So his total cost price is 40x plus 160x. His total selling price is 1.8x into 120. This is 200x. This is 216x, or a profit of 8%. 200 to 216, 200x to 216 is nothing but 100 to 108, a profit of 8%. Capture data clearly and you're through. Medium quality is x, good quality is 2x. 80 of this, 40 of this. Total cost is 40x, 160x. Total cost price is 200x. The price is 10% less than this, which is 1.8x. All the mangoes are sold at this price, or 120 mangoes sold at this price. The total selling price is this much. He buys at 200x, sells at 216x. His profit percentage is 8%. If Fatima sells 60 identical toys at a 40% discount on the printed price, then she makes 20% profit. So identical toys, 40% discount on printed price. So printed price, let's say, is x. So selling price is 0.6x. So 40% profit. Cost price is 0.5x. How did we get there? It's a 20% profit, not 40%, 20% profit. So selling price should be 1.2 times cost price. So if this is 0.6x, that is 1.2 times cost price, or cost price is 0.5x, which is what we got here. 10 of those toys are destroyed in fire. While selling the rest, how much discount should be given on the printed price so that she can make the exact same amount in profit? So this is if she sells 60 identical toys. Now she doesn't get to sell 60, she sells only 50. And so her total cost price is 0.5x into 50 into 60, which is 30x. She needs to make a 20% profit. So from 30x, she has to realize 36x. She has to make 36x from just 50 goods, or he should sell at 0.72x. Her printed price is x. Her selling price should be 0.72x, or she gives a 28% discount. Going over the whole process, for 60 toys, the numbers look like this. Printed price is x, selling price is 0.6x because discounted by 40%. This returns a 20% profit, or my cost price is 0.5x for each of the goods. Therefore, the math works. However, she's not able to sell everything. She loses 10 of the toys. So in the new scenario, she buys 60 but sells only 50. But she wants to see the same profit. If she buys 60, she sees cost price of 30x. She has to make 20% profit, or she should have a total selling price of 36x. She has only 50 items to sell now. So 36x have to be sold for 50 items. Each item, the good is 0.72x. Or what was at x now has to be sold at 0.72x, or we can discount by 28%. Time to travel. Let ABC be a right angle triangle with BC as hypotenuse. I love right angle triangles. AB and AC are 15 and 20. 15 and 20 is in the ratio 3:4. So I know this is a 3, 4, 5 triangle. So AB is shorter, AC is longer. BAC 15, 20, 25. 3, 4, 5. The minimum possible time in minutes required to reach the hypotenuse from A at a speed of 30 kilometers per hour. From A, we reach the hypotenuse. When the minimum possible distance would happen, the minimum possible time would happen if you're traveling the minimum possible distance, which means it's a perpendicular line. And so we want to find distance AD and then divide that by 30 kilometers per hour. How do we find that? We can use the idea of similar triangles, but better still would be area of this triangle ABC can be written as half into BA into AC, or half into BC into AD. It's probably the best method to find the altitude to the hypotenuse. Or 15 into 20 into half equals half into 20 into 80, half into 25 into 80. half disappears. This is 5, this is 3, 4, AD is 12 units. You're traveling 12 kilometers at 30 kilometers per hour. This is 2 by 5 of an hour, or 2 by 5 into 60, 24 minutes. You want the time in number of minutes, that is 24. Fine. Pythagoras theorem, finding the altitude and then doing distance by speed equal to time. A class consists of 20 boys and 30 girls. In the mid-semester examination, the average score of the girls was 5 higher than that of the boys. Fine. Boys and girls. Fine. 20 and 30. Average of boys was n, girls would have been n plus 5. That means the overall average, I already know this difference is 5. The overall average would have been n plus 3, closer to the girls than to the boys, split in the ratio 2:3. In the final exam, however, the average score of the girls dropped by 3, while the average score of the entire class increased by 2. So average of the entire class was n plus 3. This would have gone to n plus 5. Average score of the girls dropped by 3, so the girls would have gone to n plus 2 from n plus 5. While the average, what will the increase in the average score of the boys? Now n plus 2 and something would have resulted in n plus 5. This difference is 3. Ratio should be 2:3. So this difference should be 4.5. I'm talking about the alligation method. So this should have been n plus 9.5, or the average score of the boys would have increased by 9.5. And wonderful question, beautiful question, done with the approach of alligations. And so what we're doing here, initially the boys to girls ratio is 2:3. So boys were n, girls were n plus 5. So if you subtract and get here, you should get 2:3. The difference between these two numbers is 5. So the 2:3 gets split as 2 and 3. So this should have been n plus 3. N plus 5 minus n plus 3 is 2. N plus 3 minus n is 3. You've got this far. And then we know the average score of the girls dropped by 3. N plus 5 becomes n plus 2. Of the average score of the entire class increased by 2. N plus 3 becomes n plus 5. So you're mixing something and n plus 2 in the ratio 2:3 to get n plus 5. So this something should have been n plus 9.5. From n, we add 9.5 to go to 9.5. It's a classic question where algebraically you can get to the answer, but if you think along the way of using this alligation method, you are running to the answer, racing to the answer, getting it right. So wonderful, wonderful question where one method is significantly superior to another one. And you can rush to the answer if you can just think in terms of splitting the difference. Between n and n plus 5, the difference is 5. Break that in the ratio 2:3, you've got your weighted average. So wonderful way of thinking about weighted average. So if you're mixing 80 and 90 and mixing it in the ratio 2:3, you can do 2 into 80, 3 into 90 by 5, or you can say the difference is 10. I'll break this in the ratio 2:3. So that is 4 and 6. So this number should, mixing 80 and 90 in the ratio 2:3, it becomes 4 and 6, or I can find this number to be 86. Fine. Wonderful approach. If you can think like that, you're doing these questions really quickly. So keep that in mind. The area of the closed region bounded by the equation mod x plus mod y equal to 2, the two-dimensional space is fine. I know this question, I know this shape, so I'm going to rush to the answer, and then we'll discuss how we can get this. Mod x plus mod y equal to 2 is a shape like this. How do we get that? In all of these questions, put one of the two is 0. Put y equal to 0, x could be 2 or minus 2. So 2, 0 and minus 2, 0 sits here. A symmetric shape. Therefore 0, 2, 0, minus 2 also sit. If x and y are both positive, that is, we are in this quadrant, mod x plus mod y equal to 2 is just x plus y equal to 2. You have a straight line like this. 1, 1 will be on this. Therefore, minus 1, 1 will be minus 1, minus 1 will be 1, minus 1 will be. So we can see this graph take shape step by step. I already know this, so I'm rushing to the answer. But rule of thumb, whenever you have a curve like this, put y equal to 0, see where it cuts the x-axis. Put x equal to 0, see where it cuts the y-axis. You have modulus here and modulus here. That means if a point p comma q sits on this, p comma minus q can sit on it, minus p comma q can sit on it, minus p comma minus q can sit on it. The way it looks in the first quadrant, everything else is going to be symmetric of that. Therefore, if you draw this, you can frame the whole thing. So mod x plus mod y equal to 2. This distance is 2. This distance is 2. So this is 2 root 2. Area here is 2 root 2 into 2 root 2. It's a square of side 2 root 2. 2 root 2 to 2 root 2. That is 8 square units. Let ABC be a right-angled isosceles triangle with hypotenuse BC. So I am already liking this question. I like isosceles right-angled triangles. BCA. The sides are in the ratio 1:1 is to root 2, and the angles are 45, 45, 90. Let BQC be a semicircle away from A with diameter BC. The other semicircle would have passed through A because of the right angle. Let BPC be an arc of a circle centered at A and lying between BC and BQC. If AB has length 6 centimeters, so BPC be an arc of circle centered at A and lying between BC and BQC. So it's an arc like this. Wonderful. If AB has length 6, the area in square centimeters of the region enclosed between BPC and BQC. We're looking at this. Again, it's a standard question, but we'll solve this through to completion anyway. Right? How do we do this? We find area of, this is Q, this is P. Right? So we find area of the semicircle BQC. From that, we subtract area of this segment BPC. How do we find area of this segment? This is 1/4 because it's a right of pi into 6 square. So 1 quadrant of a circle of radius 6 minus half into 6 into 6. So this segment is 1/4 of pi into 6 square minus half into 6 into 6. So sector minus triangle gives us this segment, right? Which is 1/4 of 36 pi, 9 pi minus 18. Now this we need to subtract from the larger semicircle. Semicircle BQC that has BC measures 6 root 2. So radius of that semicircle is 3 root 2. Area is pi into 3 root 2 whole square into 1/2, which is pi into 9 into 2 into 1/2, or 18, 9 pi. From 9 pi, we subtract 9 pi minus 18. 9 pi minus 9 pi minus 18, which is 18 square units. Which is effectively area of this triangle. So this part is equal to area of this triangle. It's another way of thinking about it, which is linked to the idea that that you're talking about we're incorporating Pythagoras theorem in some form. So area of this triangle is half into 6 into 6, 18, which is nothing but area of that crescent shaped region. A solid metallic cube is melted to form 5 solid cubes whose volumes are in the ratio 1:1:8:27:27. We add all of this, 27, 27, 8, 1, 1. It adds up to 64. So we could have imagined a large cube of size 4 by 4 by 4. It would have had 64 pieces. Then we have 1, 1, 8, 27, 27. And the percentage by which the sum of the surface areas of these 5 cubes exceeds the surface area of the original cube is nearest to. Original cube has area 6 into 4 square. These are the 5 small cubes. They will have radii one side of the cube equal to 1, 1, 2, 3, 3, The area would be 6 into 1 square plus 1 square plus 2 square plus 3 square plus 3 square. So from 6 into 4 square, it goes to this. Think about percentage increase. So we just need to worry about the ratio. 4 square is 16. So we can forget about the 6. 1 plus 1 plus 4 plus 9 plus 9. This 9 plus 9 is 18. 18 plus 6 is 24. 16 to 24. It's an increase of 8. 8 or from a base of 16, or we are looking at 50%. A ball of diameter 4 centimeters is kept on top of a hollow cylinder standing vertically. So hollow cylinder standing vertically. The height of the cylinder is 3 centimeters. Its volume is 9 pi centimeter cube. Pi r square height is 9 pi. R square into 3 is 9, or R is root 3. Radius is square root of 3. A ball of diameter 4 centimeters is kept. Then the vertical distance in centimeters of the topmost point of the ball from the base of the cylinder. It's a wonderful question. So the diameter here is 2 root 3. So when you place a ball of diameter 4 centimeters, 2 root 3 is 3.4. So this ball is not going to go through this and fall in. It's not going to be held at its peak here, but it's going to be something like this, right, with the center being somewhere here. Now think about this. From the center of the ball, draw if you draw a line to this point, the midpoint, then diameter is 4, or this is 2. This is root 3. And so if you imagine this shape, then this point, the center of the spherical ball that is sitting on top of the cylinder, to the center of the circle, that is the topmost layer of the cylinder, let's say that is P, and the end point, which is of that diameter, basic diameter, let's say Q, and this shape OPQ is a right angle triangle. This is root 3, this is 2, this is a 1 root 3 2 right angle triangle. OP is 1. So the center of our ball of diameter 4 centimeters is 1 centimeter above the top circle of this cylinder. So we want to find the topmost point here. From O further up, you have to go 2 centimeters, and then 1 centimeter to get to the top cylinder, plus 3 centimeter. Or the topmost point is at a distance of 3 centimeters plus 1 centimeter plus 2 centimeters, 6 centimeters from the base of the cylinder. The total distance of the topmost point from the base is 6 centimeters. X plus 1 equal to x square. It's a wonderful algebraic question. We want to find 2x power 4. And so we want to find 2x power 4. So we can either find x square minus x minus 1 equal to 0. That means x square minus x plus 1 by 4 equals 1 plus 1 by 4. We take this minus 1 this side and adding 1 by 4 on both sides. X minus half the whole square is 5 by 4. With this we can find x. Right? So our x minus half is plus or minus root 5 by 2. X is half plus or minus root 5 by 2. X is positive, so it is only half plus root 5 by 2. And then we have to find 2x power 4. So even after you have found x, finding x square, x power 4, that's going to become trickier. So we're going to think about finding x power 4 algebraically. And we have an x square here, so square this. X power 4 equals x square plus 2x plus 1. Now x square is x plus 1. So x plus 1 plus 2x plus 1 is x power 4. Or 3x plus 2 is x power 4. Or 6x plus 4 equals 2x power 4. We want to find this, we only need to find this. X is 1 plus root 5 whole by 2. We want to find 6x plus 4, where x is 1 plus root 5 by 2. 6 into 1 plus root 5 by 2 plus 4. So this is 3 times. So 3 plus 3 root 5 plus 4, or 7 plus 3 root 5, or 3 root 5 plus 7. There goes this answer. Key thing here to somehow find x and then write x power 4 in terms of x. If you manage that, this becomes a far simpler question. The value of log root 5 to the base 0.008 plus log 81 to the base root 3 minus 7. What is this equal to? And this can be written in terms of 5. This can be written in terms of 5. These two can be written in terms of 3. Root 5 is 5 power 1 by 2. 0.008 is 2 cube by 10 cube, or this is 5 power minus 3. 1 by 5, 1 by 5 square, 1 by 5 cube, 1 by 125 is this number. I'm going to write this as log root 5 by log 0.008. Write this as log 81 by log root 3. Choose this base to be 5, this base to be 3 minus 7. Log root 5 is 1 by 2 by minus 3. 5 power minus 3 is 0.008. So log 0.008 base 5 is minus 3. Plus log 81 to the base 3 is 4 by 1 by 2 minus 7. This is 8. 8 minus 7 is 1. This is minus 1 by 6. This whole thing becomes minus 1 by 6 plus 1, which is 5 by 6. This is minus 1 by 6. This is 8 minus 7. So minus 1 by 6 plus 1 is 5 by 6. This is a choice we're looking for. 9 power 2x minus 1 minus 81 power x minus 1 equals 1944. Wonderful. I'm going to write this in terms of 9 power x minus 1. So 9 power 2x minus 1 minus 9 square to the power x minus 1 equals 1944. 9 power 2x minus 1 minus 9 power 2x minus 2 equals 1944. This is 9 power 2x minus 2 into 9 minus 9 power 2x minus 2 is 1944. 9 power 2x minus 2 into 8 is 1944. Let's do 1944 divided by 8. We should be through. 2, 16, 34, 4, 32, 3. And so, or 9 power 2x minus 2 equals 243. 243 is 3 power 5. This is 9 power 5 by 2 is 243. Or 2x minus 2 equals 5 by 2. 2x equals 9 by 2. X is 9 by 4. Wonderful question. Manipulate with exponents. Get comfortable with the idea of dealing with exponents. These questions, either we treat this, sometimes we go to a quadratic mode. We'll say 9 power 2x minus 1, let it be y, and then simplify. Or we get something in common. Between these two expressions, 9 power 2x minus 2 is common. Once you get that, this becomes a very simple question. After that, it's just doing a little bit of algebra and keeping it together. Nothing more than that. The number of solutions x comma y comma z to the equation x minus y minus z equal to 25. X, y, z are positive integers. X is less than or equal to 40. Y is less than or equal to 12. Z is less than or equal to 12. Right. Or the maximum values y and z can take are 12. Maximum x can take is 40. Right. So let's think about this. From 40, we subtract this. We subtract something to get 25. From 40, I'm just going to put some numbers here. 40 minus 12 minus 3 equal to 25. 40 minus 15 is 25. X can be 40. Y can be 12. And Z can be 3. when x is 40, this works. And when x is 39, I'm going to go step by step. X equals 40. That means y plus z equals 15. And x is 39, y plus z equals 14. X is 38, y plus z equals 13, and so on. Right? So x is less than or equal to 40, y less than or equal to 12, z less than or equal to 12. How do we simplify this? We can take individual values for x and then find the number of possibilities for y and z. If y plus z equal to 15, y is less than or equal to 12. So y could be 12, z could be 3, and then we have 11, 4. So y can take values 12, 11, 10, 9, all the way till 3. And z can take the corresponding other values. From 12 to 3, this is a set of 10 values. When x is 40, y plus z equal to 15, there are 10 possibilities. Right? Y can go up to 12 and z can go up to 12. So y can take all values from 3 to 12. Here again, y can go to a maximum of 12, and from y can range from 12 all the way till 2. 12 to 2, there are 11 values. Y plus z equal to 13, y can go from 12 to 1, there are 12 values. When x is 37, y plus z is 12, y can go, x, y, z are positive integers, 11 to 1, 11 values. X is 36, y plus z is 11, y can go from 10 to 1, 10 values. Fine. So x is 35, y plus z is 10, y can take from 9 downwards, 9 values. And I'm going to go to the next slide. What we have here, values, the number of values that can be taken. We've done till x equal to 35. I'm going to go from x equal to 34, 33, but the values we have here, 10, 11, 12, 11, 10, 9, 10, 11, 12, 11, 10, 9. X equals 34, y plus z should be equal to 9. Y can start from 8. We have 8 values. Here we'll have 7 values, 32, 6 values, 31, 5 values, 34 values, 29, 3 values, 28, 2 sets, 27, 1 set. When it's 27, you have only one possibility. So we have 1 plus 2 plus 3 plus 4 all the way till 10, 12, plus 10 plus 11, or 12 into 13 by 2 plus 21. 12 into 13 by 2, 6 into 13, 78, plus 21, which is 99. This is what they're looking for. Going step by step, plugging in x equal to 40, 39, 38, all the way till 27. X cannot be less than 27 because y and z are positive integers. They have to be at least 1. How many integers n will the inequality n minus 5 into n minus 10, which is n square minus 15n plus 50 minus 3n plus 6 less than or equal to 0 be satisfied? I'm going to see if we can factorize this first. N square minus 18n plus 56 less than or equal to 0. 14 into 4, n minus 4 into n minus 14 less than or equal to 0. So n should lie between the roots. It is less than or equal to 0. So n can take values from 4 to 14, 4, 5, 6, 7, 8, all the way till 14. This is 11 values. Very simple question. Take this, simplify this, factorize it. There's a quadratic equation with 2 positive roots, and it should be less than or equal to 0. N should lie between the 2 positive roots, between 4 and 14. How many integers are there with between 4 and 14, including 4 and 14, because there's a less than or equal to 0 sitting here. f1 of x is x square plus 11x plus n. f2 of x is x. Then the largest positive integer n, for which the equation f1 of x equal to f2 of x has 2 distinct real roots. These two should be equal. Then we have x square plus 10x plus n equal to 0. This should have equal to distinct real roots, or the discriminant should be greater than 0. Discriminant is b square minus 4ac, which is 10 square minus 4n greater than 0. 100 minus 4n greater than 0, or 25 minus n greater than 0, or the maximum positive integer n can take 24. If n were 25, this will have equal real roots. Anything more than 25, this will have no real roots. If you want two distinct real roots, n has to be less than 25, largest positive integer less than 25, that is 24. Equate these two, get to the quadratic, and then put discriminant greater than 0. Done. A, B, C, D are integers such as a plus b plus c plus d equal to 30. The minimum possible value of a minus b whole square plus a minus c whole square plus a minus d whole square is, remember, all three are positive. And so we need to minimize the difference between a and b, a and c, a and d. And so we can try to have all four numbers as equal. Put this as 0, put this as 0, put this as 0. But that's not possible because 30 is not a multiple of 4. Remember, whenever there's a difference, the difference is going to be an integer, but they're all integers. And you square an integer, the larger the difference is, the larger the square is going to be. So we should find a to be as close to b, c, d as possible, and all four numbers to be very close to each other. 30 by 4, 7.5. So a, we should peg it at 7 or 8. All four at 7 or 8. We have 2 7s and 2 8s, this will work. 7, 7, 8, 8. A minus b whole square will be 0. A minus c whole square is 1. A minus d whole square is 1. 0 plus 1 plus 1 is 2. Wonderful. So this looks like this will be the minimum. Let's convince ourselves. Fine. So if the difference is more than 1 anywhere, if we did just that difference square is going to be 4. So we cannot have 0 plus 0 plus 4 or 0 plus 0. We have one difference being 2. We cannot go lower than this. So all the maximum should be 1. So better than 0, 0, 1, we should look for 0, 0, 0, 1, 1. We should look if there is a possibility 0, 0, 1. A equal to B equal to C, and D being slightly further away. And so 8, 8, 8, 6 doesn't work. 7, 7, 7, 9 doesn't work. 7, 7, 8, 8 is the best possibility, or the least is 2. Done. A, B, C, D, E, F, G, H, and J, K be 5 diameters of a circle with center at O. Wonderful. A, B, C, D, E, F, G, H, and G, K. 5 diameters of a circle with center at O. In how many ways can 3 points be chosen out of A, B, C, D, E, F, G, H, J, K? 5, 6, 7, 8, 9, 10 and O, so as to form a triangle. And so any 3 points lying on a circle are non-collinear. So there are 11 points here. I'm going to break this down. We're basically saying from this 11, how can you select 3 points that are not collinear? I'm going to break this as some 10 of these. And so some 10 of these, out of these 10, you select any 3. They'll be non-collinear. Any 3 points on a circle are not collinear. Fine. Wonderful. Now let's think about O separately. And let's have O here at the center. Then out of the remaining 10, we can select some 2. That's the way to go about it. Take O and then select some 2 out of the remaining 10. That'll happen in 10C2 ways. However, if the 10 included A, B, C, D, E, F, G, H or J, K, then we're talking about collinear lines. This will not be a triangle. This will not be a triangle. This will not be a triangle. Those we'll have to subtract. Those we'll have to remove. So to 10C3, add 10C2. And then from this, subtract 5. The 5 selections of A, B, C, D, E, F, G, H and J, K. A, O, B, C, O, D, E, F, O, G, O, H, J, O, K will not be triangles. Pretty much anything else will be a triangle. So 10C3, 10 into 9 into 8 by 1 into 2 into 3. 10C2, 10 into 9 by 2 minus 5. So this is 3, 8 into 4, 8 by 2 is 4, 120 plus 45 minus 5, 120 plus 40, 160. You could imagine this as 11C3, 11 into 10 into 9 by 1 into 2 into 3. This is 3, this is 5, 15 into 11 is 165 minus 5. That's the other way of thinking about it. Effectively, out of the 11 points, select any 3. And then from that, subtract the selections of the 5 diameters. So 11C3 minus 5 or 10C3 plus 10C2 minus 5. Both ways we get to 160. The shortest distance of the point half comma 1 from the curve y equal to mod of x minus 1 plus mod of x plus 1 is, think about the point half comma 1, right? From the point half comma 1 to this point, let's put half into this. If you put x equal to half, modulus of half minus 1 plus modulus of half plus 1. This is 1 by 2 plus 3 by 2. Y should be 2. Half comma 2 is a point on this line. It seems to be a very interesting curve. Y will be entirely positive. That much we know. I'm going to imagine and draw this curve, even if it takes a while. This is going to be, y is entirely positive. It's going to be a set of straight lines. I'm going to put a bunch of values. Let's say we put x equal to 0. Then y will be 2. 0 comma 2. When x equal to 1, when we put x equal to 1, we'll have 1 minus 1 0, 1 plus 1 2, 1 comma 2 is a point. X equal to minus 1, that will be a point here. And so x equal to 1 by 2, half minus 1 is modulus is 1 by 2, 3 by 2, y equal to 2, minus 1 by 2, that will also be a point. So think about this, a wonderful graph. And so I'm going to break this into 3 segments. And when x is greater than 1, this will be x minus 1 plus x plus 1. We're talking about 2x. When x is less than minus 1, this will be 1 minus x minus 1 minus x. It will be minus 2x. And so this will be a line like this here and a line like this here. Between minus 1 and 1, it will be 1 minus x plus x plus 1. It will be 2. So there's a point like this. It is 2 from minus 1 to 1, and then a curve with step 2x here and a slope of plus 2 here, slope of minus 2 here. Curves going up. You're looking at a point half comma 1. So half comma 1. The shortest distance will be this perpendicular distance, which will be 1 unit. Draw the graph. The key points here, if you're given just modulus, you're going to deal with straight lines. Keep that in mind. Best way to go about it, find points. Find the scenarios where put x equal to 0 and see if y can be 0. We can see where it meets the x-axis. Whenever you have modulus, break it along the modulus lines. What do I mean by that? X greater than 1, x less than minus 1, between minus 1 and 0. F of x equal to mod x. This means f of x equal to x when x is greater than 0, equal to minus x when x is less than 0, equal to 0 when x is equal to 0. You can put either of this as greater than or equal to or less than or equal to. Imagine that modulus equation like that, reconstruct that, and then you're through. Anytime you have only modulus come in, remember you're dealing with a set of straight lines. That is very crucial. That helps. Imagine the diagram. You put a bunch of points, you can connect them with straight lines, then we are good. If the square of the seventh term in an arithmetic progression with positive common difference equals the product of the third and 17th terms, then the ratio of the first term to the common differences. Seventh term of an arithmetic progression, a plus 6d whole square equals a plus 2d into a plus 16d. Then we need to find a by d. A square plus 12d plus 36 equals a square, 12ad plus 2ad plus 16ad plus 32d square. A square gets knocked off. This is 36d square. Sorry. So 36d square, 32d square. So this is 4d square plus 12ad minus 18ad equal to 0, or 4d square equals 6ad. Common difference is not 0. 4d equal to 6a. We want to find a by d. This is 4 by 6, which is 2 by 3. We told we're dealing with positive common difference, and we need to, I'm just thinking about why that should have been the case. So we told positive common difference. I'm just thinking why that should be the case. Are we cancelling a d square somewhere? Cancelling only a d somewhere, and we're dealing with equal to. So the ratio should be 2:3. In how many ways can 7 identical erasers be distributed among 4 kids in such a way that each kid gets at least 1 eraser, but nobody gets more than 3 erasers? So a plus b plus c plus d equal to 7. Each kid gets at least 1. That's natural numbers. So a plus b plus c plus d equal to 7. Dealing with natural numbers. Nobody gets more than 3 erasers. So think about this. Let's forget this 3 eraser constraint. So we have 1, 2, 3, 4, 5, 6, 7 erasers put among 4 kids. Just like saying I'm distributing some plus symbols here. If I put 3 plus symbols somewhere in these slots, then I'm good. There are 6 slots, and I have to select 3 plus symbols among them. 6 C3 ways of doing this. I've forgotten this constraint, remember. So 6 C3 ways are there of distributing 7 identical erasers among 4 kids. So 6 C3 is 6 into 5 into 4 by 1 into 2 into 3, which is 20. The 20 ways of doing this, we don't keep this constraint. Now let's think about it. Let's say nobody gets more than 3 erasers. Let's say one kid gets more than 3 erasers. So one kid could get 4 or 5 or 6 or 7. Let's say 4. If this kid gets 4, each of them has to get 1, because at least 1 is required. Only one way this kid can get 4. Nobody can get more than 4. So the only possibility is 4 1 1 1. That could be 1 4 1 1 1 1 4 1 1 1 1 4. One kid could get 4 erasers. It could be any one of the 4 kids. So from 20, subtract 4. We have 16 ways of doing this. F of x equals 5x plus 2 by 3x minus 5. G of x is x square minus 2x minus 1. X minus 1 the whole square minus 1. G of f of 3. I'm going to find f of 3 first. 5 into 3 plus 2 by 3 into 3 minus 5. 15 plus 2, 17 by 9 minus 5, 4. So that is f of 3. We want to find f of 3, or we want to find f of 17 by 4. It is 5 into 17 by 4 plus 2 by 3 into 17 by 4 minus 5. This is 85 plus 8 by 4 by 51, 3 into 7 is 51 minus 20. Wonderful. So this is 93 by 31, which is 3. Brilliant. F of 3 is 3. So we need to find G of 3. G of 3 is can be written as x minus 1 the whole square minus 2. This is 2 square minus 2, which is 4 minus 2, 2. Or x square, 3 square minus 2 into 3 minus 1, 9 minus 6 minus 1, which is 2. Just substituting, being very careful about the numbers. Luckily enough, we get a 3 here. You're through. Let A1, A2, A3 till A3n be an arithmetic progression with A1 equal to 3, A2 equal to 7. So the common difference is 4. And then we have A1 plus A2 plus A3 all the way till A3n equal to 1830. What is the smallest positive integer m such that m times A1 plus A2 plus A3 till an is greater than 1830? And we can find n and then simplify and find this. It's probably going to be the simplest method, but I think the first 1/3, second 1/3, third 1/3. And so you can reimagine it slightly differently. We might be able to solve this quickly. I think the answer would be 9 or 10, but I'm going to do this step by step. And so sum of n terms of this AP, common difference, I'm going to forget n, put 3n equal to k. And sum of k terms of the AP, k by 2, 2a plus k minus 1 into d is 1830. K by 2 into 2 into 3 6 plus k minus 1 into 4 is 1830. K by 2 into 6 plus 4k minus 4 is 1830. This is 2 plus 4k, 1 plus 2k. K into 1 plus 2k is 1830. And we can solve this. 2k square plus k minus 1830 is 0. 1830, we need to factorize it between k and 2k plus 1, between two numbers reasonably close by. And so let's divide this by 6. This can be written as 6 into 305. That's far away. 305 is 61 into 5. So 30 into 61 works. So k is 30. 3n is 30 or n is 10. And we need to add this till 10 terms. Let's do that. 10 by 2 into 2 into 3 plus 9 into 4. And 2a plus n minus 1 into d. So this is 5 into 6 plus 36. 5 into 42, which is 210. 210 into m should be greater than 1830. 21 into m should be greater than 183. 21 into 9 is 189. 9 works. So I'm just doing it methodically, finding 3n, then finding n, then substituting and finding m. 21 into m is greater than 189. So m equal to 9 works. Ratio of a square and b square. It's a wonderful, wonderful question. A and b are integers of opposite signs, such that a plus 3 whole square is to b square is 9:1. A plus 3 whole square by b square is 9. Or a plus 3 by b is plus or minus 3. Likewise, a minus 1 by b minus 1 whole square is 4. Or a minus 1 by b minus 1 is plus or minus 2. And or a plus 3 is 3b or minus 3b. Right? If a plus 3 is 3b, a minus 1 is 3b minus 4. A is 3b minus 3 or minus 3b minus 3. So a minus 1 is 3b minus 4 by b minus 1, or minus 3b minus 4 by b minus 1. This is equal to plus or minus 2. This is equal to plus or minus 2. Why are we solving all of this? Because we're given squares. So what are we trying to do? We're going to find the ratios for all of these. Fine, and then see the scenarios where a and b are integers and of opposite signs. And so let's start with the first one. This one, 3b minus 4 by b minus 1. Fine, so I'm going to 3b minus 4 by b minus 1 is 2, or 3b minus 4 is 2b minus 2, b equals 2. And if you put b equal to 2, then b minus 1 whole square is 1, a minus 1 whole square is 4, a is 3 works. In this case we have substituted a is 3b minus 3, b equal to 2 gives us a equal to 3. These are integers, but they are not integers of opposite signs, so this doesn't work. If we put 3b minus 4 by b minus 1 is minus 2, we get 3b minus 4 is minus 2b plus 2, or 5b is 6, b is 6 by 5. This doesn't work because we want b and a to be integers and of opposite signs. The other equation, minus 3b minus 4 by b minus 1 is 2. So minus 3b minus 4 is 2b minus 2. Minus 3b minus 2b is minus 2 plus 4. Minus 5b is 2. b is minus 2 by 5. That doesn't work. The last variant, hopefully this will work. Minus 3b minus 4 is minus 2b plus 2. But take this as minus 2. Or minus 3b plus 2b is 2 plus 4, which is 6. b is minus 6. And b is minus 6. In this case we have made the assumption that a is minus 3b minus 3. a should be minus 3 into minus 6 minus 3, which is 18 minus 3, 15. Fine, so a is 15, b is minus 6 works. 15 plus 3 square is 18 square, minus 6 square is 6 square, this is 9. 15 minus 1 is 14 square, is 2. Minus 6 minus 1 minus 7 square, this is 4. This works. 15 and minus 6 works. A square is to b square is 15 square by 6 square, which is 5 square by 2 square. 25 is to 4. This is the answer choice we're looking for. Very doable question, just that this ratio could be plus or minus 3 when you take the square root. A plus 3 by b could be plus or minus 3. A minus 1 by b minus 1 could be plus or minus 2. Plug in all 4. Only one combination where we get integer values for a and b and of opposite sign. That's the value of a and b. Plug in a square is to b square. We got 25 is to 4. Log x to the base 3 is a. Log y to the base 12 is also a, where x and y are positive numbers. If g is the geometric mean of x and y, the log g to the base 6 would be log x to the base 3 would be a, or x is 3 power a. Log y to the base 12 is a, or y is 12 power a. Geometric mean is square root of xy, which is square root of 3 power a into 12 power a, which is square root of 36 power a. Square root of 36 power a, this is square root of 6 power 2a. 6 power 2a whole power 1 by 2, which is 6 power a. So the geometric mean is 6 power a. Log g to the base 6 be a. Go back to the idea of expressing in terms of exponents. Go from logarithms to exponents, and then we are through. Log x to the base 3 is a, or x is 3 power a. This step 1 in logarithms. Be very comfortable with that. But 90% of the questions start and end with this. Nothing more than that. X is 3 power a, y is 12 power a, x into y is 36 power a, which is 6 square whole power a. Right? Or square root of that is just 6 power a. And then you're through. Magic square. The numbers 1, 2, 3, 4 till 9 are arranged in a 3 by 3 square grid in such a way that each number occurs once, and the entries along each column, each row, and each of the two diagonals add up to the same value. And so they all add up to the same value. And so the top left and the top right entries of the grid are 6 and 2 respectively. Then the bottom middle entry is. And so to start with, 1 to 9 are all distributed. The total of all this should be 9 into 10 by 2, which is 45. Each row adds up to the same number. Each column and each row add up to the same number. 3 rows make up the whole grid. So any sum, the sum has got to be 15. Right? Now let's put the numbers in. We know that the top left and top right entries of the grid are 6 and 2. Top left is 6, top right is 2. 6 plus 2 is 8, so this should be 7. And so these three add up to 15. As a simple rule of thumb in all of these magic square questions, you can take it for granted that the middle number, which is going to be part of this, and this, 4 different sums, is going to be the middle number. From 1 to 9 you arrange, 5 in the middle, put the number bang in the middle, 7 plus 5 is 12, 12 plus 3, 15, and then you can fill the rest out. Everything else falls in place. There are probably still 1 or 2 variants available, but the sum is 15. The key idea here, find the total sum. Therefore, you are able to find the sum of each row or each column. Each row, each column, each diagonal all add up to 15. And so now you can fill the entire grid. So 6 plus 5 is 11. This will be 4. 2 plus 5 is 7. This will be 8. This automatically adds up to 15. 6 plus 8, 14 plus 1. This is 9. Everything is 15. This is the entire grid. So we want to know then the bottom middle entry. Bottom middle entry is 3. The answer should be 3. When you stick in the middle number in the middle, and then this kind of question become very simple. Find the total of everything put together. That is 45. So each row, each column should add up to 15. Then work from there on. In a 10-kilometer race, A, B, and C, each running at uniform speed, get gold, silver, and bronze medals. If A beats B by 1 kilometer and B beats C by 1 kilometer, that means in this 10-kilometer race, when let's say A, B, and C start here, when A finishes, B has done only 9 kilometer. When A does 10, B does only 9. And then a little while later, B finishes. At that time, C is done only 9 kilometer. B beats C by 1 kilometer. Just remember, only one thing we need to remember. A, B, C are not at the 10 kilometer, 9 kilometer, 8 kilometer point. If B beats C by 1 kilometer, this means when B finishes the race, when B is at the end point, then C is at the 9 kilometer point. After this, this is a plain old-fashioned ratio question. When A does 10, B does 9. When B does 10, C does 9. And then by how many meters does A beat C? That means when A is finishing, how much has C done? When B does 10 kilometers, C does 9. When B does 8 kilometers, C will do 9 into 9 by 10, which is 8.1. When A does 10 kilometers, C does 8.1 kilometers, or C lags behind by 1.9 kilometers. Remember, we need to give the answer in meters. This is 1900 meters. So the answer is 1900. Bottle 1 contains a mixture of milk and water in the ratio 7:2, and bottle 2 contains a mixture of milk and water in the ratio 9:4. In what ratio of volumes should the liquids in bottle 1 and bottle 2 be combined so that the mixture of milk and water is 3:1 in the final combination? The key thing in all of this, don't track milk to water ratio. Don't track this. Track milk by overall or water by overall. One of these two. So I want to say this is 7/9 milk. This is mixed with 9/13 milk in some ratio to give us 3/4 milk. 7/9 milk is mixed with 9/13 milk to give us 3/4 milk. And what ratio should we be mixed this? Is the allegations approach So this will be 7 by 9 minus 3 by 4. This will be 3 by 4 minus 9 by 13. 7 by 9 is more than 9 by 13. And so 7 by 9 minus 3 by 4, LCM is 36. So 3 by 4, 7 by 9, 9 fours are 36, 7 fours are 28. 28 minus 27 by 36. This is 1 by 36. 4 and 13, the LCM is 52. 3 by 4 is 39 by 52. 9 by 13 is 36 by 52. So this is 3 by 52. Or they should be mixed in the ratio 3 by 52 is to 1 by 36. And so this can get knocked off. So it'll become 18, becomes 26. So get further knocked off, this will become 9, this will become 13. Or the ratio is 27 is to 13. And this allegations method is very useful. Look at the allegations method, do 5 questions, see the proof of the allegations method, intuitively get why the allegations method works. Think about the notion of splitting the difference, but it is frightfully useful. The computational part is not that easy, but it's doable. But there's a very regular question. This way of mixing 2 mixtures to get 1 mixture and then finding the ratio, it's very simple. Get some practice in, you should nail these questions. Arun's journey. Arun drove from home to his hostel at 60 miles per hour. While returning home, he drove halfway along the same route at 25 miles per hour and then took a bypass road which increased his driving distance by 5 miles but allowed him to drive at 50 miles per hour along this bypass road. If his return journey took 60 minutes more than his onward journey, then the total distance traveled by him is. So let's say he goes from home to hostel. Let's say this is a distance of 2d. Why 2d? Because there's some number which says half the distance. And so he takes this route at 2d, he travels one way. Second time around, he drove half the route d and then took a bypass which increased the distance by 5 miles, made it d plus 5. This is the bypass. And while going, I'm going to assume that this d is in miles. The time taken would have been 2d by 60. While returning, the time taken would have been d by 25, because this he's traveling at 25 miles, and d plus 5 by 50, plus d plus 5 by 50. This is onward journey. This is return journey. Time taken difference will be in terms of hours. We've assumed d in miles. This is miles per hour, miles per hour, miles per hour. This will be in hours. This will be in hours. Right? His return journey took 30 minutes more than his onward journey. 30 minutes more than his onward journey. That means half an hour more. Onward journey would have taken d by 30, 2d by 60, plus half equals d by 25 plus d by 50 plus 1 by 10. D by 25 plus d by 50 more, it is 2d by 50. So this is 3d by 50. So d by, so 1 by 2 minus 1 by 10 equals 3d by 50 minus d by 30. 1 by 2 minus 1 by 10 is 5 by 10 minus 1 by 10. 5 by 10 minus 1 by 10, which is 4 by 10, which is 2 by 5. This side is 2 by 5. That side LCM of 50 and 30 is 150. So I'm going to write this in the next page. So 3d by 50 minus d by 30 is equal to 2 by 5. LCM is 150. 3d into 3 is 9d. d into 5 is 5d. So this is 4d by 150. 2 by 5 equals 4d by 150. This I'm going to make it as 2d. 150 by 5 is 30. d by this is 15. d by 15 is 1, or d is 15 miles. Remember, we're talking about his total journey. That means he traveled 2d and then d sorry, and then d plus 5. You're traveling 4d plus 5, 60 plus 5, 65 miles. The question says the total distance traveled by him. Onward he traveled 2d, return journey he traveled d, and then a d plus 5 because of the bypass. So 4d plus 5 is the answer we are looking for, which is 65 miles. Construct the right equation, then this becomes a very routine question. But the shirts produced in a factory, 15% are defective, while 20% of the rest are sold in the domestic market. So 100% to start with, 85% is non-defective, 80%, 20% are sold in the domestic market. So 80% of 85% is what is sold in the export market. 80% of 85% of X equals 8840. 80% is 4 by 5, 85% is 17 by 20 equals 8840. We need to find X. You're through. You're given a calculator, but you probably don't need this. Cancel the 4, 884 divided by 4 is 2210. 221 is 17 into 13. So cancel this off. This is 130. 5 into 20 is 100. 100 into 130 is 13,000. This is the number you're looking for. Fine. 15% are defective or 85% are normal. 20% of the rest are sold in the domestic market, or 80% of this number are exported. 80% of 85% of X is 8840. Find X. You're through. Very routine question. You should be comprehensively nailing these. The average height of 22 toddlers increases by 2 inches when 2 of them leave this group. When 22 toddlers, let's say average is A. 20 toddlers, average becomes A plus 2. And so this is the number, this is the average, or the total height would have been 22A. Now the total becomes 20 into A plus 2, but 2 people have left. Now the 2 who leave, their average height is 1/3 the average height of the original 22. That means A by 3, 2A by 3. This is the total height of the 20 students. This is the total height of the 2. This is total of 20. This is total of 2. This is total of 22. So this plus the sum of these two should be this. We manipulate this, we should be able to find A. And we need to find the average height of the remaining 20 toddlers, or our answer is A plus 2. This framework is very useful. Number of entities into average is equal to total. And so I'm going to write this equation down. 22A equals 20A plus 40 plus 2A by 3. So 2A minus 2A by 3 is 40. 4A by 3 is 40. A is 30. A is 30 inches. We're looking at A plus 2, which is 32 inches. A manufacturer of a table sells it to a wholesale dealer at a profit of 10%. X, wholesale dealer gets it at 1.1x. The wholesale dealer sells the table to a retailer at a profit of 30%. This is 10%. This is 30%. So he sells it 1.1x into 1.3. Finally, the retailer sells it to a customer at a profit of 50%. He sells it at 1.1 into 1.3 into 1.5x. The customer pays 4290. 1.1 into 1.3 into 1.5 times x is 4290. And so 11 into 13, 11 by 10 into 13 by 10 into 3 by 2 is 4290. 4 plus 2, 6, 6 plus 9, 15. So it's a multiple of 3. So divide by 3 to start with. Becomes 1430. 143 is 11 into 13. Wonderful. This goes off, giving us a 10. Or the price is 10 into 10 into 2 into 10. 1000 into 2, 2010. this way of writing the equation, you should know. 10% more, 1.1x, 30% more, 1.3 times that, 50% more, 1.5 times that whole number. That's equal to 4290. Solve x. Very regular question. You should do this really quickly. You should have done hundreds of questions similar to this. A tank has an inlet pipe and an outlet pipe. The outlet pipe is closed. Then the inlet pipe fills the empty tank in 8 hours. If the outlet pipe is open, then the inlet pipe, outlet relieves in some time, inlet plus outlet, it takes 10 hours. Or in 1 hour, the inlet pipe can fill 1 by 8, but is able to fill only 1 by 10. Or this outlet pipes takes away 1 by 8 minus 1 by 10, 5 by 40 minus 4 by 40, or 1 by 40. In 1 hour, the outlet pipe takes away 1/40th of the tank. Or to drain an entire tank, the outlet pipe will take 40 hours. So far so good. The answer should be 40. Just wait a second. The question says, if only the outlet pipe is open, then in how many hours the full tank becomes half full, or we need to empty only half a tank? Doesn't take 40 hours. It will take only 20 hours. Find the number, but then look at what is being asked. Full tank should become half full, or half the tank should be empty. To empty an entire tank, it takes 40 hours. Half the tank will get emptied in 20 hours. Mayank buys some candies for 15 a dozen and an equal number of candies for 12 a dozen. And so let's say he buys n candies at rupees 15 by 12 each, and then n candies at rupees 12 by 12 each. He sells all of them, that is 2n of these, at 16.5 by 12 each, and makes a profit of 150. How many dozens of candies does he buy? Now I'm going to make one shift. I'm not going to worry about each candy's cost. I'm going to assume there are n dozens of each. And so n dozen at 15, n dozen at 12, 2n dozen at 16.5. And so this is 15n plus 12n. This is 33n. 33n minus 27n. Selling price minus cost price is profit, which is 6n, which is 150, or n is 25. So he buys 25 dozens at this price, 25 dozens at this price, and sells the 50 dozens at this price. Or how many dozens of candies did he buy altogether? 50. Once again, n is 25, but the answer, we are looking to answer the question, what is 2n? So it is 50. In a village, the production of food grains increased by 40%, and the per capita production of food grains increased by 27% during a certain period. And so this is number of food grains by number of people equal to per capita. And so this increases. Let's say this per capita number was x by y. Originally, it has become 1.4x by something, which happens to be 1.27 times of this number. Per capita original is this. Per capita final is this. X becomes 1.4x. So food grain production has increased. Per capita production has increased only a little, slightly lesser than this. That means this number has also gone. So x by y equal to some number. 1.4x by whatever this is 1.27 times this number, or 1.4x by something is 1.27 times x by y. Or this number we are looking for is 1.4 by 1.27 times y. And so population of the village increased during the same period is nearest to, is what we need to find. So y becomes 1.4 by 1.27 y. What is it closest to? And so this will be around 10% is my guess. So I'm just going to 1.27 plus 1.13. So it's not 13, it's less than 13%. Let's do 1.27 into 1.1. We'll see where it takes us. 127, 127, 793. This becomes 139. Sorry, 1.397. It's as close to 1.4 as possible, or 10% increase is what you're looking for. X becomes 1.4x. Y becomes some number. X by y becomes 1.27 times x by y. Find this number. This is 1.1y. That's the math we are doing. A, B, C are three positive integers such that A and B are in the ratio 3:4. A is to B, 3:4. We're dealing with positive integers. That makes life very simple. B and C are in the ratio 2:1. B is to C is 2:1, or it is 3:4:2. 2:1 is nothing but 4:2. They're positive integers. Then there could be 3n, 4n, and 2n. If you add everything up, the total is 9 times n. The following is a possible value of a plus b plus c. A plus b plus c should be a multiple of 9. Done. 207, 2 plus 7 is 9. The other three are not multiples of 9. We're looking for a multiple of 9. We're jumping with joy that we've actually found this question in the exam and not some really tricky one. A motorbike leaves point A at 1 p.m. and moves towards point B at uniform speed. And so A, B, bike leaves at 1 p.m. A car leaves point B at 2 p.m. and moves towards point A at uniform speed, which is double that of the motorbike. So motorbike travels at a speed of x, car travels at 2x. They meet at 3:40 p.m. at a point which is 168 kilometers from A. So they meet at 3:40 p.m. So 168 kilometers from A. And so from 1 p.m. to 3:40 p.m. I'm going to think in terms of hours. This is 100 minutes. Sorry, 1 to 3:40. So it is 2 hours and 40 minutes. 2 by 3, or this is 8 by 3 hours A has traveled. B at the same time has traveled not 8 by 3 hours but only 5 by 3 hours. A has traveled for 8 by 3 hours. B has traveled for 5 by 3 hours. Right? So 8 by 3 hours A travels at a speed of x. B travels for 5 by 3 at a speed of 2x. 8 by 3 into x is 168. What is 5 by 3 into 2x? This is what we are being asked. And so 8 by 3x, this is 10 by 3. This is in the ratio 8:10. 8:10 is 168 is to what? Fine. So once we find this, we can find everything else after that. 8:10 is, this is 4:5. This is 168. 168 by 4 is 84 by 2, 42. 42 into 5 is 210. Or this is 168 kilometers. This is 210 kilometers. The total distance between A and B is 168 plus 210, which is 378 kilometers. Done. Amal can complete a job in 10 days. A, 10 days. Bimal can complete it in 8 days. Amal, Bimal and Kamal complete the job in 4 days. In 1 day, Amal can do 1 by 10, Bimal can do 1 by 8. Totally, they can do 1 by 4. Or Kamal, right, in 1 day can do 1 by 4 minus 1 by 8 minus 1 by 10. Or 10 by 40 minus 5 by 40 minus 4 by 40. LCM is 40, which is 1 by 40. Fine. So Kamal will take 40 days to finish the task. They are paid total of ₹1,000 as remuneration. The amount is shared in proportion to their work. if they're shared in proportion to their work, A is to B is to K, they should be shared in the ratio 1 by 10 into 1 by 8 is to 1 by 40. I'm going to multiply by 40, ratio 4 is to 5 is to 1. Totally they get 1000 rupees. And the amount Kamal should get 1/10 of this. This 1/10 of total, 5/10 of total, 4/10 of total. Should get 1/10 of 1000 rupees, or should get 100 rupees. Key thing here, if you're given number of days you take to complete a task, you think about what gets done in one day. That's the rate. So 1 by 10, sorry, this is 1 by 8. Add these two, subtract from this, we'll get 1 by 40. Or Kamal would have taken 40 days to complete the entire task. They should share 1000 rupees. They should share in the ratio of work done, not days taken. Or they should get money in the ratio 1 by 10 is to 1 by 8 is to 1 by 4. Sorry, 1 by 40. So 1 by 10, 1 by 8, 1 by 40. Or 4 is to 5 is to 1. Kamal's share is 1/10 of the total, which is 1/10 of 1000, 100 rupees. Three mixtures. Consider three mixtures. The first having water and liquid in the ratio 1 is to 2. Liquid A in the ratio 1 is to 2. The second having water and liquid B in the ratio 1 is to 3. Third having water and liquid C in the ratio 1 is to 4. These three mixtures of A, B and C are further mixed in the proportion 4 is to 3 is to 2. Let's say 4x of A, 3x of B, 2x of C. And so how much of A, B, C and water will be there? When liquid A is 1 is to 2, water is to liquid. So 2/3 is liquid A and 1/3 is water. So 2/3 of 4x would be A. Liquid B would be 3/4 of 3x. Liquid C would be 4/5 of 2x. Water will be 9x minus all of this. And so this is 8 by 3x, 9 by 4x, 8 by 5x. And so 8 by 3, 9 by 4, 8 by 5. And then water is the remaining part. And so now we have to go with the answer choices. This is little more than 2, little more than 2, little less than 2. If we add all this up, should be close to 6. Water will be close to 3x. And so let's think about this. It has the same amount of water and liquid B. That's not the case. Same amounts of liquid B and C. That's not the case. More water than liquid B. Probably yes. More water than liquid A. Both can't be true. So let's look at the numbers in more detail. This 8 by 3, 9 by 4, 8 by 5. LCM is 60. 8 by 3, 3 into 20 is 60, 8 into 20 is 160 by 60, 9 into 15, 135 by 60, 8 into 12, 96x by 60, 160 plus 135, 295, 295 plus 96, 391 by 60, subtracted from 9x, 9x is 540 by 60x. From this we subtract this. This is 9, 13 minus 9 is 4, 4 minus 3 is 1, 149x by 60. This is 229 by 60. This is 2, 1 by 4. This is 2, 2 by 3. So the amount of water is more than liquid B but less than liquid A. More water than liquid B, that is true. More water than liquid A, that is not true. These two are not true. We're looking at choice C. The A and B are not true, clearly. Same amount of water and liquid B, not true. Same amounts of B and C, not true. More water than liquid B, that is true. Less than liquid A, so this is not true. A, B, C, D, F, E, F be a regular hexagon with each side of length 1 centimeter. So 1, 2, 3, 4, 5, 6. A, B, C, D, E, F. Now a regular hexagon is nothing but 6 equilateral triangles placed around a central point. Remember that's a very good way of thinking about a regular hexagon. Side 1 unit, 1, 1, 1, 1, 1, 1, 1, 1. All of these are 1. Right? Area of a square with side AC as one side. This AC. Think about this. If we call this as O, ABO is an equilateral triangle. ABCO is a rhombus. So this will be perpendicular and equal. So this will be root 3 by 2 times this altitude of equilateral triangle is root 3 by 2a. So we call this as P. So AP equals root 3 by 2 into 1, which is PC, or AC measures root 3 by 2 times 2, which is root 3 centimeters. Area of a square with AC as one side, if with root 3 as one side, root 3 into root 3 is 3. This will be the area. The base of a vertical pillar with uniform cross section is a trapezium whose parallel sides are of length 10 centimeters and 20 centimeters. So 10 and 20. Fine. So this is 10, this is 20. While the other two sides are of equal length. So let's say X and X. The perpendicular distance between the parallel sides is 12. So this is 12. This is 12. These two are equal, so it's an isosceles trapezium. So this should be an equal sides. So these two should be equal. This is 12. This should be 5. This should be 5. So X is 13. This is the base we are talking about. Height of the pillar is 20 centimeters. Then the total area in square centimeters of all 6 surfaces of the pillar. Remember that the pillar erected on top of this. And so that particular pillar will have as its sides 4 rectangles plus 2 trapeziums, one on the top, one on the bottom. For the 4 rectangles, one side will be the height, the other side will be 10, 20, 13 and 13. And so we'll have 4 rectangles, one measuring 10 by 20, one measuring 20 by 20 and 2 measuring 13 by 20. So 10 by 20 area is 200, 20 by 20 area is 400, 13 by 20 is 260 into 2, 520. So we're looking at 520 plus 200 plus 400. So 1020. Sorry, it is 6 plus 5 is 11, 1120. This is the sum of the 4 rectangles. So far we have not accounted for this trapezium. This trapezium into 2 is what we need to account for. And area of this trapezium is half into 12 into 10 plus 20, sum of the 2 sides. Right? So 10 plus 20 is 30, 6 into 30, 180. 180 into 2, so 360. The 2 trapeziums, area would be 2 into 180, which is 360. So we're looking to add 1120 with 360, we'll get 1480. It's a wonderful question. Key thing is to reimagine this diagram as a trapezium and another trapezium right on top with 4 rectangles sitting in between them. So we're looking at 4 rectangles, one with sides 10 and 20, one with 20 and 20, 2 with sides 13 and 20. On top of that, we are calculating area of this trapezium, multiplying it by 2. The points 2, 5 and 6, 3 are 2 end points of the diagonal of a rectangle. So 2, 6, 6, 3. If the other diagonal has the equation y equals 3x plus c, so some equation like this. This is the other diagonal. Then what is the value of c? It's a wonderful question. The key to this is we know that this is a rectangle. In a rectangle, the diagonals bisect each other. So what does that tell us? That tells us that this diagonal should pass through the midpoint of this. So the diagram looks weird. This doesn't look like it's a midpoint. So chances are the other diagonal is like this. Right? So the midpoint of this is 2 plus 6 by 2, comma 6 plus 3 by 2. 2 plus 6 by 2, comma 2, comma 5, sorry, comma 5 plus 3 by 2. 2 plus 6 by 2 is 8 by 2, which is 4. 5 plus 3 by 2, 8 by 2, 4. So this equation, y equals 3x plus 2, passes through the wonderful point 4, comma 4, which is the midpoint of the other diagonal. Or you substitute x equal to 4, y equal to 4, this should be satisfied. 4 equals 3 into 4 plus c, so c not 2, or 4 equals 12 plus c, c should be minus 8, or we are looking at the equation y equals 3x minus 8. And wonderful question. So we are effectively using the idea that the diagonals of a rectangle bisect each other. That's all we need to do. That means this diagonal y equals 3x plus c passes through the midpoint of the diagonal 2, 5, 6, 3. Once you know that, you're through. ABCD is a quadrilateral inscribed in a circle with center O. And so ABCD is a quadrilateral. Angle COD is 120 degrees. So let's draw the COD first. It's 120 degrees. BAC is 30 degrees. So let's draw this. BAC. BAC is 30 degrees. This is the center O. Then the value of angle BCD. Right, so this is 120. Right. Now this diagram looks a little weird, but it's a wonderful diagram. Angle B, wonderful question. Angle BAC is 30. There's angle on the segment. So angle BOC should be twice that, which is 60. You're going to have a tough time reorienting this diagram, but think about angle BOD. Angle BOD is 60 plus 120, which is 180 degrees, or BOD is a straight line. The diagram simply does not reflect that. Such is life. We could not have known that it will end up as a straight line. BOD is a straight line, or BD is the diameter of the circle. Angle BCD is angle in a semicircle, 90 degrees, done. If three sides of a rectangular park have a total length of 400 feet, then the area of the park is maximum when the length of its longer side is. And so wonderful. Three sides are given. Let's say x, this will be x, this is y. 2x plus y is 400. The third side should also be y. X into y should be maximum. Right, so x or y is 400 minus 2x. X into 400 minus 2x should be maximum, or x into 200 minus x should be maximum. When is that maximum? Think about it. X into 200 minus x should be maximum. X into 200 minus x, that should be maximum. When x is 1, this will be 1 into 199. When x is 2, 2 into 198, 3 into 197, all the way 100 into 100. Go further, it will become 150 into 50. Further, we go all the way to 199 into 1. Think about this. 150 into 50 is 7,500. This is 10,000. The numbers keep on increasing till they become equal, and then keep fall, or their maximum when x is 100. This is 100. This is 100. This is 200. This is 200. Area of the park is maximum when x is 100 and y is 200, the length of the longest side, which is y, should be 200 feet. If three sides add up to 400, then 2x plus y equals 400. We can maximize x plus y. Sorry, we can maximize x into y when x is equal to 100, y equal to 200. Let P be an interior point of a right isosceles triangles ABC with hypotenuse AB. And the hypotenuse is AB. This is A, B, C. These two are equal. This is 45. This is 45. The perpendicular distance of P from each of AB, BC and CA. So from here, the perpendicular distance is equal, and each time it is 4 into root 2 minus 1. That means P is the in-center. When the sides are in the ratio 1 is to 1 is to root 2, I'm going to call it A root 2. And this distance, since all three are equal, we're effectively talking about P being the in-center. Or we have a right isosceles triangle whose in radius is 4 times root 2 minus 1. Or in any right triangle which sides A, B and H, in radius is A plus B minus H by 2. You should know this. When chosen a right isosceles triangle with A root 2, A plus minus root 2A by 2, A plus B minus H by 2 is 4 times root 2 minus 1. Or 2A minus root 2A by 2 is 4 times root 2 minus 1. I want to contrive a root 2 minus 1 here. So I'm going to write this as root 2A times root 2 minus 1 by 2 equals 4 times root 2 minus 1. Or A by root 2 equals 4. A is 4 root 2. So this side is 4 root 2. This side is 4 root 2. Area in square centimeters of the triangle ABC is half into 4 root 2 into 4 root 2. Root 2 into root 2 is 2. That disappears. We're talking about 16 square centimeters. If the product of three consecutive positive integers is 15600, and the sum of the squares of these integers, I'm going to guess this, 15600. We have to have two zeros. So we need to have something ending in 0 or something ending in 5. Otherwise we won't get a 0. The product has two 5s in it. We're not just 1 5, 2 5. 156 is 12 into 13. 15600 is 12 into 13 into 100. You have 100 sitting here. So there are two zeros that need to come. So we need to have two 5s and even numbers. Two 5s can come. There's a 25 sitting there because the two numbers cannot be multiples of 5 in three consecutive integers. I'm going to write this as 25 into 4 into 12 into 13. We have bingo. This is 24 into 26 into 25. That is 15600. I don't want to frame equation and solve this. We'll just factorize this and jump in. Two zeros here. The product of n into n plus 1 into n plus 2 should have a multiple of 5 square, 25 in it. If n or n plus 1 or n plus 2 is a multiple of 5, then none of the other two can be a multiple of 5. So the entire 5 square comes from one of the numbers. One of the numbers is a multiple of 25. 24 into 25 into 26 works. The sum of the squares of these integers, 24 square plus 25 square plus 26 square, 576, 625, 676. 6 plus 6, 12, 12 plus 5, 17, 1, 7, 8 plus 2, 10 plus 7, 17, 7, 1, 6, 6, 6, 18, 1, 8, 7, 7, we're through. If x is a real number such that log 5 to the base 3 is log 2 plus x to the base 5, and log 5 to the base 3 is log 2 plus x to the base 5, then which of the following is true? Log 5 to the base 3 is greater than 1. Log 3 to the base 3 is 1. 3 power a number more than 1 is this. log 5 to the base 3 is less than 2. Log 3 to the base 3 is 1. Log 9 to the base 3 is 2. We want to find a range of x. So log of 2 plus x to the base 5 is greater than 1. Log of 2 plus x to the base 5 is less than 2. Or 2 plus x is greater than 5. 2 plus x is less than 5 square. Or x is greater than 3. 2 plus x is less than 25, or x is less than 23. 3 less than x less than 23. We're going to get a narrower range than this. Log 5 to the base 3 is much more than 1. So probably x is not just greater than 3, x is probably greater than 5 or 6. And log 5 to the base 3 is much less than 2. So x is probably less than 20 even. X might lie in a narrower range, right, between 5 and 20 or 6, and we can find the precise value of x. Right? But this is one range as a starting point. If this range satisfies only one of the answer choices fitting this range, we are through. If that's not the case, then we'll have to revisit this. And 0 less than x less than 3, that doesn't work. 23 less than x less than 30, that doesn't work. If x is more than 23, this side will become more than 2. X greater than 30, that doesn't work. This should work. This is precisely this range. We're done. Just substituting two nice endpoints and then we are through with this question. F of x equal to x square and g of x equal to 2 power x. What is the value of f of g of x plus f of g of x plus g of f of x at x equal to 1? We're looking for let's find f of g of x plus g of f of x at x equal to 1. Then we'll worry about finding f of this. Right? So g of 1 is 2 power 1, this is 2. F of 1 is 1 square, which is 1. This number becomes f of 2 plus g of 1 at x equal to 2, at x equal to 1. And we're substituting x equal to 1. G of 1 is 2, f of 1 is 1. Right? Now f of 2 is 2 square, which is 4. G of 1 is 2 power 1, which is 2. So this sum at x equal to 1 is 6. We need to find f of 6. F of 6 is 6 square, 36. Done. Juicy, wonderful, easy question. So we would love it if all our questions were like this. Substitute x equal to 1, find this expression, be careful with the math. That's it. Nothing more than that. Sum of squares of roots. The minimum possible value of the sum of the squares of the roots of the equation is the roots p and q. The two roots, a quadratic. We want to find the minimum value of p² plus q². We know the sum of the roots and product of the roots formulae. Sum of the roots p plus q is minus b by a, which is minus of a plus 3. pq is c by a, which is minus of a plus 5. p² plus q², we want to write this in terms of p plus q and pq. It will be p plus q whole square minus 2pq. This will be p² plus q² plus 2pq minus 2pq. Or this expression is going to be minus of a plus 3 the whole square minus 2 times minus of a plus 5. Or this is a square plus 6x, a square plus 6x plus 9 plus 2a plus 10. And or this is a square plus 8a plus 19. So now we want to find the minimum value of a square plus 8a plus 19. The best way to do it would be the completion of squares. A square plus 8a plus what would make this a square? Something of the form a plus k the whole square. A square plus 8a plus 16 will work. This a square plus 2ax plus 2ak plus k square. So it should be 4. A square plus 8a plus 16 plus 3. This is 19. So we write this 19 as 16 plus 3. Or this is a plus 4 the whole square plus 3. The minimum value this can take is 3. That is when a is minus 4. Or the minimum possible value is 3. Super. We want to find 9 power x minus half minus 2 power 2x minus 2 equals 4 power x minus 3 power 2x minus 3. 9 power x minus half is 9 power x by 9 power half minus 2 power 2x by 2 square equals 2 square whole power x minus 3 power 2x by 3 cube. And so 9 power x by 3, which is 3 power 2x by 3 minus 2 power 2x by 4 equals 2 power 2x minus 3 power 2x by 27. I'm going to bring the 3 powers to one side, 2 powers to one side, see where that takes us. So 3 power 2x by 3 plus 3 power 2x by 27 equals 2 power 2x plus 2 power 2x by 4. And so this is 9 times 3 power 2x plus 3 power 2x by 27 equals 4 times 2 power 2x plus 2 power 2x by 4. 3 power 2x into 10 by 27 equals 5 into 2 power 2x by 4. This 5 gets knocked off. We have a 2 here. This becomes 3 power 2x into 8 equals 2 power 2x into 27. And so think about this. This is 3 power 2x minus 3 equals 2 power 2x minus 3. This is possible only when both of these are 0, or 2x minus 3 should be 0, x should be 3 by 2. Wonderful question. A bunch of simple ideas to keep in mind. A power 9 power x minus half is 9 power x by 9 power half. Something power half is square root. And then manipulate with exponents rules, you'll get to the answer. It's a very doable question, but you'll be very methodical and understand the rules of exponents very clearly. Log of 2 power a into 3 power b into 5 power c is the arithmetic mean of log of 2 square into 3 cube into 5, log of 2 power 6 into 3 into 5 power 7, and log of 2 into 3 square into 5 power 4. Or this expression is this plus this by 3. And so, or 3 times log of 2 power a into 3 power b into 5 power c is log of 2 square into 3 cube into 5 plus log of 2 power 6 into 3 into 5 power 7 plus log of 2 into 3 square into 5 power 4, or 2 power 3a into 3 power 3b into 5 power 3c equals 2 square into 2 power 6 into 2 power 1 into 3's into 5's. We need to find only a, so forget about 3's and 5's. 2 power 3a is 2 power 9. 3a equals 9, a equals 3. It's 2 square, 2 power 6, 2 power 1. That will become 2 power 9, which is 2 power 3a. A is 3. Done. Because we don't need to find b and c, we don't worry about powers of 3 and powers of 5. A1, A2, A3, A4, A5 be a sequence of 5 consecutive odd numbers. So A1, A2, A3, so I'm going to call this as n, A3 as n minus 2, n minus 4, n plus 2, n plus 4. Consider a new sequence of 5 consecutive even numbers ending with 2A3. So this is A3 ending with 2A3. 5 consecutive even numbers. If sum of the numbers in the new sequence is 450. So I'm going to think about the new sequence as m plus 2, m plus 4, m minus 2, m minus 4. 2A3 is the last number. That happens to be m plus 4. Fine. Now adding all this, we get 450, or the middle number is 90. 5m is 90, so 92, 94. 94 is 2a3. 2a3 equals 94, or a3 is 47. This is 47, 49, 51. So a5 should be 51. The key learning here, or the only big learning here, the only important point here, if you have 5 terms in an AP, anchor it around the middle term. Average of any number of terms in AP is the middle term. Median, mean, both are the middle term. So 5 terms in AP, 5 times the middle term is sum of all terms. So sum of these 5 terms is 450, middle term is 90. Middle term is 90, that means the last term is 94. Last term is 2a3, 2a3 is 94, a3 is 47, a4 is 49, a5 is 51. How many different pairs a comma b of positive integers are there such that a is less than or equal to b and 1 by a plus 1 by b is 1 by 9? So beautiful question. A is less than or equal to b. 1 by a plus 1 by b equals 1 by 9. Think about this. Let's simplify this. If we have two numbers adding up to 1 by 9, and so we cannot have either number to be, we're talking about positive integers, we cannot have either number to be greater than 1 by 9. Very simple idea. We know that a and b are both greater than 9. And very simple idea. Right? So 1 by a plus 1 by b is 1 by 9. We cannot have 1 by 2 plus a positive term to be 1 by 9. That's impossible. A and b, we're talking about positive integers. A and b should both be greater than 9. Right? So the simplest idea to think about is 1 by 18 plus 1 by 18. This is 1 by 9. So a and b can be 18 comma 18. That is one possibility. Half and half equal 18 comma 18. Now a is less than or equal to b. So this number 1 by a will be high, 1 by b will be lesser. A is less than or equal to b, so this works. 1 by 18 plus 1 by 18 is 1 by 9, or a should be less than or equal to 18, b should be greater than or equal to 18. If I increase a and b, the total will become smaller. If I decrease both a and b, the total will become greater than 1 by 9. I want 1 by a plus 1 by b to be 1 by 9. That means one number equally split is 1 by 18 and 1 by 18. So we cannot have both less than 1 by 18. We cannot have both more than 1 by 18. Or this number should be, that a should be less than or equal to 18. B should be greater than or equal to 9. We know a and b are both greater than 9. Right? That much we know. Right? So a should be less than or equal to 18. A should be greater than 9, or a can take values 10, 11, 12, 13, 14, 15, 16, 17, 18. 2, 3, 4, 5, 6, 7, 8, 9 possibilities. Of this, 18 works. Right? Now we can think of 1 by b as 1 by 9 minus 1 by a. So 1 by 9 minus 1 by any of this, wherever it will become a nice 1 by b, where b is an integer, we are through. Straight away you can sense that 17 won't work. 1 by 9 minus 1 by 17. 17 minus 9 by 17 into 9. This doesn't, it won't factorize, that's out. 1 by 18 minus 1 by 9 minus 1 by 16. Nothing in common. Be 7 by something. Doesn't work. 15 could work. 1 by 9 minus 1 by 15. So the denominator could be 45. 5 by 45 minus 3 by 45. 2 by 45. Funnily enough, that doesn't work. 14, not likely to work. 1 by 9 minus 1 by 14. 14 minus 9 by 14 into 9, not possible. 13, 1 by 9 minus 1 by 13, won't work. 12 might work. It has to have something in factor with 9, in common with 9. 1 by 9 minus 1 by 12. 36 is common. 4 minus 3 by 36. 1 by 36. Yep, that works. A equal to 12, B equal to 36. That is a possibility. So 12 works. 11, 1 by 9 minus 1 by 11 is 2 by 99. Doesn't work. 10, 1 by 9 minus 1 by 10 is 10 minus 1, 1 by 90. That can work. 10 works. A equal to 9, B equal to 90 works. So 18, 18 works, 12, 36 works, 9, 90 works. Nothing else can work. A cannot be 9, B being infinity, that's not possible. So 3 pairs work. So wonderful question, tough question. A little bit of math, a little bit of trial and error. Key thing to notice here is to start with 18, 18 works. And after that, one of A and B has to be less than 18, other has to be more than 18. So A is less than or equal to 18, B is greater than or equal to 18. A cannot be less than 9. It cannot even be equal to 9. So from 10 to 18, that's a set of possible values A can take. Go step by step. We can forget about primes. We can forget about numbers that have nothing in common with 9. All those will just weed themselves out. Worry about the remaining. We are through. In how many ways can 8 identical pens be distributed among Amal, Bimal and Kamal such that Amal gets at least 1, Bimal gets at least 2 and Kamal gets at least 3 pens? Amal 1 plus something, Bimal 2 plus something, Kamal 3 plus something. And let's say 1 plus x, 2 plus y, 3 plus z. Right, so 1 plus x plus 2 plus y plus 3 plus z equals 8, or x plus y plus z is 8 minus 6, which is 2. And x, y and z have to be whole numbers. Right? Or we can write this as x plus 1 plus y plus 2 plus z. In this case we want x plus y plus z equal to 8 minus 3, which is 5. Here we are solving for x, y, z being natural numbers. Here x, y, z being whole numbers. And both are same. You can redefine this any which way. So we can call it 1 plus y, 2 plus z, where x, y, z are natural numbers. At least 1, at least 2, at least 3. Or 1 plus x, 2 plus y, 3 plus z, where x plus y, x, y, z are whole numbers. Now if we're talking about this, then it's like 5 ones. Some 2 slots we need to put a plus symbol out of these 4, which can be done in 4C2 ways, which is 6 ways. We can even list down and find. We have A, B, K. Give him 1. Let's give Bimal 2. 1 plus 2 is 3. We need to have total of 5. Amal being 1, this could be 3, this could be 4. Amal being 1, this could be 4, this could be 3. We cannot have 1, 2, 5, 1, 3, 4, 1, 4, 3. These 3 possibilities exist with Amal getting 1. We cannot have 5 for Bimal, then Kamal will have only 2. That's not possible. Put 2 for Amal, 2 for Bimal, 4 for this. Or 2, 3, 3. We cannot have 2, 4, 2. Amal having 3, Bimal having 2, 3 plus 2, 5, 5 plus 3, 8. With 3, that's the only possibility. With Amal gets 4, then Bimal 2 and Kamal 3, that's not possible. Or these are the 6 possibilities. We can list them down and find out, or we can be slightly more formulaic about it. Both work, obviously. How many 4-digit numbers which are divisible by 6 can be formed using the digits 0, 2, 3, 4, 6, such that no digit is used in more than once and 0 does not occur in the leftmost position? We're looking at 4-digit numbers. Fine. So there are 5 digits here. Out of these 5, 1 should be left out. Should have a multiple of 6. That means it should be a multiple of 2 and a multiple of 3. So it should be an even number. That's also a multiple of 3. Now 2 plus 3 plus 4 plus 6 plus 0. I added all the digits. 2 plus 3 is 5. 5 plus 4 is 9. 9 plus 6 is 15. This is 15. This is a multiple of 3. And all of this, it will be a multiple of 3. So if we drop something, then that should also be a multiple of 3. Or if we drop the multiple of 3, that will work. Or we could have the digits as 2, 4, 6, 0, 2, 3, 4, 0, or 2, 3, 4, 6. 2 plus 4 plus 6, 12, that's a multiple of 3. 2 plus 3 plus 4, 9, that's a multiple of 3. 2 plus 3 plus 4 plus 6, This is 15. That's a multiple of 3. Fine. So the digits could be 2, 4, 6 and 0, 2, 3, 4 and 0, 2, 3, 4, 6. All of these are possible. Right? Now with these 4 digits, we want to have the number of possible even numbers that are there. 2, 4, 6, 0, all 4 are even numbers. And so we can say any 4-digit number formed with these, that should work. For the first digit, there are 3 possibilities. It cannot obviously be 3. That's ruled out. The first digit cannot be 0. So that cannot be one of the possibilities. So 3 possibilities. Second digit, 3 possibilities. Third digit, 2 possibilities. And 1 possibility for the last digit. 3 into 3, 9. 9 into 2, 18. 18 possible numbers. With 2, 3, 4, 0. Fine. We need to look at even numbers. Now there's a complication here. We cannot just worry about the total number of numbers because the last digit cannot be odd. And so since there's only one odd digit, let's find out the total and then subtract the combination where there's a last digit. Right. So total possibilities is the first digit cannot be 0. So 3 options for this, 2, 3 or 4. Whatever this is, that should not be in the second digit. 3, 2, 1. So 3 into 3, 2 into 1, 18 possibilities exist for this. Of this 18, there will be some combination where the last digit is 3. And that means 2, 4, 0 go here, but 0 cannot go into the first slot. So 2 possibilities here, 2 possibilities here, 1 possibility here. 4 such numbers are possible. We're talking about 2, 0, 4, 3, 4, 0, 2, 3, 2, 4, 0, 3, 4, 2, 0, 3. Subtract these 4, 14 numbers are possible. And so 18 numbers with these digits, 14 with these digits. 2, 3, 4, 6. Now there's no 0 constraint. So totally there are 24 numbers possible, rearranging this. Of these, if you have to have the last digit as 3, 2, 4, 6 get rearranged in 3 factorial ways. Out of the 4 factorial, 3 factorial numbers, 3 factorial different combinations will be odd numbers. So 4 factorial minus 3 factorial, 24 minus 6, 18 numbers work, satisfying both our condition. That it should be an even number and should be a multiple of 3. So 18 numbers with these digit combinations. 18 plus 18, 36, 36 plus 14, 50. 50 numbers are possible, all of which are 4-digit numbers that are divisible by 3 using the digit 0, 2, 3, 4, 6 such that no digit is used more than once, or each digit appears exactly once, whichever 4 digits are chosen. So 50 numbers are possible totally. Brilliant, brilliant, brilliant question. First isolate the digits that can be possible, then count rigorously. Make sure we account for 2 conditions. The last digit should be even, first digit should not be 0. F of a comma b is f of a into f of b for all positive integers a and b. Then the largest possible value of f of 1. See, f of a into b is f of a into f of b. It's a into b. I'm going to put b as 1. F of a into 1 is f of a into f of 1. Or f of a is f of a into f of 1. Or f of a into f of 1 minus 1 is 0. There are 2 possibilities here. Remember this. Either f of a is 0 or f of 1 is 1. Either this could be a constant function where f of all values is 0. Then f of a into b will be equal to f of a into f of b. In which case f of 1 will also be 0. Or f of 1 is 1. In which case there are different values possible, but f of 1 is 1. That much we know. The largest possible value of f of 1 is 1. When f of 1 could either be 1 or it could be 0. If the constant function f of a equal to 0, then f of 1 will also be 0. If that is not the case, then f of 1 is 1. The largest possible value of f of 1 is 1. Let f of x equal to 2x minus 5 and g of x equal to 7 minus 2x. Then modulus of f of x plus g of x equals modulus of f of x plus modulus of g of x if and only if. So let's worry about this. This is easy to form. Modulus of 2x minus 5 plus 7 minus 2x equals modulus of 2x minus 5 plus modulus of 7 minus 2x. 2x minus 5 plus 7 minus 2x is modulus of 7 minus 5, which is mod 2, which is 2. Modulus of f of x plus g of x is 2. We need this to be 2. Now, modulus of 2x minus 5, modulus of 7 minus 2x. This breaks at 5 by 2. This breaks at 7 by 2. What do I mean by that? Greater than 5 by 2, we'll call it as 2x minus 5. Less than 5 by 2, we'll call it as 5 minus 2x. Fine. Likewise, 7 minus 2x goes to 0 at 7 by 2. So we'll worry about the expression being 7 minus 2x and 2x minus 7, depending on that range. 5 by 2 and 7 by 2 are our pivotal points. So our answer choice is going to be anchored around that. Right? So now think about this. We have 0 here, 5 by 2 somewhere here, 7 by 2 somewhere here. X is greater than 7 by 2. X is less than 5 by 2. X sits between 5 by 2 and 7 by 2. Those are our three possibilities. Right? Less than 5 by 2. If x is less than 5 by 2, x is say 2, then this will be 2 into 2 minus 5, which is minus 1. Modulus of minus 1 is plus 1. So here there will be 5 minus 2x plus modulus of 7 minus 2x. If x is less than 5 by 2, this will stay as 7 minus 2x plus 7 minus 2x. This will be 12 minus 4x. And I'm just breaking it into three ranges. Fine. So 0 to 5 by 2, the expression will be like this. Fine. So when x is less than 5 by 2, modulus of 2x minus 5 is of the form 5 minus 2x. When x is greater than or equal to 5 by 2, modulus of 2x minus 5 will be 2x minus 5. Likewise, when x is less than 7 by 2, modulus of 7 minus 2x will be 7 minus 2x. When x is greater than or equal to 7 by 2, modulus of 7 minus 2x will be 2x minus 7. Fine. So this is how this function breaks. Therefore, if you're looking at 0 to 5 by 2, 5 by 2 to 7 by 2, greater than 7 by 2. And 0 to 5 by 2 we have done. Now we're going to think about not 0 to 5 by 2, less than or equal to 5 by 2. Then this expression becomes 12 minus 4x. We're going to talk about 5 by 2 less than x less than 7 by 2. In this range, the expression will be x is more than 5 by 2. This will be 2x minus 5. X is less than 7 by 2 plus 7 minus 2x. This is 2. X is greater than or equal to 7 by 2. This will become 2x minus 5 plus 2x minus 7, which is 4x minus 12. So here it is 2. Fine. In these two ranges, it doesn't work. Fine. So the answer looks like it is this, but we have to be very careful here. When x is equal to 5 by 2, 12 minus 4 into 5 by 2 is also 2. That's equal to 7 by 2, 14 minus 12. That also works. So this right here is not the answer choice. This is the answer choice. X could be 5 by 2. X could be 7 by 2. Both are possible. So x lies between 5 by 2 and 7 by 2, all right. But it is close to interval 5 by 2 to 7 by 2. Both of those values are indeed possible. So worry about this. Don't do all this and mark this as the answer choice. It's a wonderful, wonderful question. So 5 by 2 less than x less than 7 by 2. That works. This range works. That is if x is there, but only if, then you have to mark this. Because x could be 5 by 2, x could be 7 by 2. That possibility also needs to be considered. So keep that in mind. An infinite geometric progression a1, a2, a3 has the property that an equals 3 times an plus 1 plus an plus 2 and so on. Infinite terms. For every n greater than or equal to 1. a1 plus a2 plus a3 all the way till 32. Sum of infinite terms of a1 is 32, or the first term being a by 1 minus r is 32. Fine. A equals 3 times a2 plus a3 and so on. This is also an infinite sequence. In this expression, I am putting n equal to 1. A2, this is geometric progression with the first term being AR and the sequence being 1 minus R, or this is A equals 3 times A into R by 1 minus R, or 1 minus R equals 3R, 1 equals 4R, R equals 1 by 4. A by 1 minus R is 32. A equals 32 into 1 minus 1 by 4. A is 32 into 3 by 4, which is 24. We want to find A5. A5 is AR power 4. A5 equals AR power 4. A is 24. R power 4 is 1 by 4 whole power 4. So this is 24 into 1 by 4 into 1 by 4 into 1 by 4 into 1 by 4. 24 by 4 is 6. This is 2, 3. This is 3 by 2 into 4 into 4, 3 by 32, wherever the choice is. A1 is 1 by 2 into 5, A2 is 1 by 5 into 8, A3 is 1 by 8 into 11, all the way till A100. And so, how do we do this? This is going to be something of this form. Finally, we have to sense this: A minus B plus B minus C plus C minus D all the way till something. So a bunch of terms are going to get cancelled and we're going to be left with something in the end. The method, getting a sense of the method is very important. We're going to somehow fall back into the idea of partial fractions. And so if you can sense that, that is brilliant. Fine. So first up, we need to find the 100th term. This is 1 by 2 into 5, 5 into 8, 8 into 11. We're going plus 3, plus 3, plus 3. So A1 is 2 into 5, A2 is 5 into 8. So I'm going to define AN as 1 by n plus 1 into n plus 4. So A2 is, 5 into 8. This goes up in steps of 3. 1 by 3n minus 1 into 3n minus 3n plus 2. This is an. First term is 1 by 2 into 1 by 5. Why 3n? Because this goes up in steps of 3. So these are anchoring around multiples of 3. I'm going to link A1 to 2, A2 to 5, A3 to 8. What is this sequence? This is 3 minus 1, 6 minus 1, 9 minus 1. So this first term is 1 by 3n minus 1. Second term is this plus 3, 3n plus 2. Right? And so on. So 100th term will be 1 by 3 into 100 minus 1. 3 into 100, 300 minus 1, 299 into 302. That's the 100th term. We're going to break this open using the idea of partial fractions. How so? Start with, I'm going to go back to this. Let's get back to pointer mode. 1 by 2 into 5. So I'm going to think about it as 1 by 2 minus 1 by 5. LCM is 2 into 5. Numerator is 5 minus 2. 3 by 2 into 5. 1 by 5 minus 1 by 8. 5 into 8. 8 minus 5, which is 3 by 5 into 8. Or imagine this like this. 1/3 of this will be 1/3 of this, which is 1 by 2 into 5. 1/3 of this will be 1/3 of this, will be 1 by 5 into 8. Or this giant expression can be written as 1/3 whole of 1 by 2 minus 1 by 5 plus 1 by 5 minus 1 by 8 plus 1 by 8 minus 1 by 11 all the way to 1 by 299 minus 1 by 302. Fine. Just like how we had outlined, a minus b plus b minus c plus c minus d plus d minus c all the way till one final term. Bunch of things get cancelled. This will get knocked off, this will get knocked off, this will get knocked off. Everything will get knocked off till there. Or we are looking at 1 by 3 times 1 by 2 minus 1 by 302. 302 and 2, LCM will be 302, this will be 151. So this is 1 by 3 times 151 minus 1 by 302. This is 1 by 3 times 150 by 302. This is 50 by 302 or 25 by 151. Just this choice. Fine. Key thing here, you're looking at partial fractions. You're looking to break these into fractions such that you have a bunch of terms that get cancelled. 1 by 1 into 2 is 1 by 1 into 1 by 2. 1 by 2 into 3 is 1 by 2 minus 1 by 3. 1 by 3 into 4 is 1 by 3 minus 1 by 4. Likewise, 1 by 2 into 5 is 1 by 2 minus 1 by 5. 1/3 of this. The numerator becomes 3. So I'll have to knock that off. So this whole expression becomes 1/3 of 1 by 2 minus 1 by 5, 1 by 5 minus 1 by 8, 1 by 8 minus 1 by 11, all of those added. So a bunch of terms will get cancelled. We'll be left with 1/3 of 1 by 2 minus 1 by 302. That is 151 by 302 minus 1 by 302, or 150 by 302, 1/3 of that. 50 by 302, which is 25 by 151. From a triangle ABC with sides of lengths 40, 25 and 35, a triangle portion GBC is cut off, where G is the centroid of ABC. Fine. So ABC G is the centroid. And so 40, 25 and 35. 40, 25, 35. Fine. So 5 is common. I'm going to think of this as, take out that 5. The ratio is 8, 5, 7. So whatever I find, I'll find for 8, 5, 7. And then incorporate this 5 later on. So 8 into 5, 7, 5 into 5, 7 into 5. And I'm going to think of this as an 8, 5, 7 triangle. And then BGC, G is the centroid of ABC. Area in square feet of the remaining portion of the triangle ABC. The remaining we need to find. To start with, one very interesting nugget that we should probably know is the centroid carves a triangle into 3 parts of equal area. BGC, ABG, AGC, they're all equal in area. So this area will be 1/3 area of the triangle. Remaining will be 2/3 of area of triangle ABC. 1/3, 1/3, 1/3. BGC will be 1/3 of area of triangle ABC. So remaining, what we need to find is the area of the remaining portion of the triangle. And this very crucial point, this remaining portion. I did this question completely once, even had the video up, where I had found the area of BGC and not the remaining. And so how do we go about solving this? We'll try to find area of triangle ABC and then take this number, multiply that by 2/3, and then we are through. BGC is 1/3, that is cut off. And so area of triangle ABG, how will we do that? We'll find the perimeter. I'm going to think about this as 8, 5, 7. Include this right at the end. Perimeter is 8 plus 5, 13. 13 plus 7, 20. Or semi-perimeter is 10. S minus A, this minus the first number is 2. 10 minus 5 is 5. 10 minus 7 is 3. S minus A, S minus B, S minus C in some order. Right? So our area of triangle ABC. And so triangle ABC area is some multiplying factor, because it's 5 times. The multiplying factor is 5 square, 25, into area of triangle of sides 875. Each side is 5x this. So every number will be 5 times that. Think of area as half into base into height, so that the factor gets involved twice over. The answer should be 25 into that. Now I'm going to do the computation. I know semi-perimeter is 10. S minus A, S minus B, S minus C are 2, 5, 3. So area is square root of 10 into 2 into 5 into 3. This is area of triangle of sides 8, 7 and 5. This into 25, because now I'm not thinking about 8, 7, 5. I'm thinking about 40, 35, 25. This into 2 by 3, because here we are thinking about remaining portion, not BGC, but the remaining portion. Fine. Wonderful. 10 into 2 into 5 into 3. Fine. So 10 into 2, 20, 20 into 5 is 100, or this is 10, 10 into 10, then the root 3 remaining. So 2 by 3 into 25 into 10 root 3. There's a 2 tens here, you take it out of the square root, it becomes a 10. So this is 250 into 2, 500 by 3 times root 3, which is nothing but 500 by root 3, choice B. Just a recap, the idea involved here, a centroid divides it into 3 equal parts. We want to find the remaining, that is 2/3 of the large triangle. Triangle has 40, 25, 35, our ratio is 8, 5, 7. Find this and then multiply by 25, because you've carved out, you divided each side by 5. So there's a double impact, base into height, a square impact, an area impact. So 8, 5, 7, plug in our s into s minus a into s minus b into s minus c square root formula, find the area and find the value.